You know, every single time you use your phone, there's this incredibly sophisticated security system that just springs to life. And right at the heart of it all is a multi-layered fortress of cryptographic keys. Today, we're going to build that fortress piece by piece so we can really understand the brilliant design behind LTE's key hierarchy. So here's our plan. First, we'll look at the big problem the designers were trying to solve. Then, we'll build up the key system, layer by layer. We'll see how it splits up different kinds of traffic, watch the cryptography do its thing, and then finally, see how this all paves the way for 5G.
All right, let's dive right in. To really get why the solution is so smart, we have to start with the fundamental challenge they were facing.
Just think about it for a second. What if your entire digital life on your phone, every call, every text, every website you visit, was all locked down by just one single key? The stakes would be unbelievably high.
It's a classic domino effect, right? If you have one key for absolutely everything and that key gets out, the whole system just collapses. An attacker wouldn't just steal one piece of the puzzle, they'd get the whole box. It's a catastrophic single point of failure, and that is exactly what LTE was designed to prevent. So what's the solution? Well, it's a core security principle, compartmentalization. Instead of putting everything in one big, vulnerable room, you build a fortress with tons of separate, individually locked chambers. If one chamber gets breached, hey, the others are still safe and sound. LTE security is built on this very idea. So how does LTE actually build this fortress? Well, it all starts with the foundation, what we call the anchor and mobility keys. The whole process kicks off with a root of trust that's living right there inside your phone, a secret key called KI. That's stored safely on your SIM card. After your phone proves it's you and authenticates with the network, that secret is used to create the very first major key of the session, the K_ASME. Now, the KSME has a really cool job. Think of it as the master anchor for your entire connection. It basically links your identity to the network session, and this is absolutely crucial, it is never used to encrypt your actual data. Its only purpose is to be the secure parent from which all other keys are born.
Let's go to the next layer down and see how this gets even smarter. From that master anchor key, the KASME, the network derives a totally new, more specialized key called the KENB. And this is where the security starts getting really clever about where you are in the world. You see, the KENB is tied directly to the specific cell tower, the eNode B, that you're connected to at that very moment. So as you're driving down the road and your phone seamlessly hands off from one tower to the next, a brand new KENB is generated for each and every connection. This gives us what we call mobility security. It means even if an attacker somehow managed to compromise one tower, they couldn't follow you to the next one. Your security literally gets a fresh start with every move you make.
Okay, so now we've got a key for our specific connection to the cell tower. But LTE gets even more granular. It actually creates different keys for different types of jobs.
Basically, all your network traffic gets split into two distinct streams. First, you have the control plane. This is for all the back-end signaling, the commands that manage your connection. It's so important that both encryption and integrity protection are absolutely mandatory. Then you have the user plane. This is your stuff, your voice call, your web browsing. It's always encrypted, but to maximize speed, integrity protection is sometimes optional.
Okay, so we've got all these specialized keys. Now let's get into what they actually do, the cryptographic heavy lifting.
To protect your data, LTE uses a whole suite of strong, modern encryption algorithms. The one you hear about most is AES, the Advanced Encryption Standard, which is pretty much the gold standard for securing data all over the world. We are talking about serious, well-vetted, powerful cryptographic tools.
And you have to understand, this was a massive leap forward from the older mobile technologies. GSM, or 2G, relied on ciphers that, frankly, are now considered weak and totally breakable. LTE's jump to modern ciphers like AS was a fundamental, game-changing upgrade for global mobile security.
Now, beyond just keeping things secret, security is also about making sure you can trust what you're receiving. Integrity protection does just that. It guarantees that the messages being sent between your phone and the network haven't been secretly tweaked or tampered with by an attacker. This is absolutely critical for stopping all kinds of manipulation attacks.
So here's how it works. When the network sends a critical command, it calculates a special cryptographic signature called a Message Authentication Code, or MAC, and it just sticks it on the end. You can think of this MAC like a digital tamper-proof seal.
Now, if an attacker intercepts that message and tries to change even one tiny thing, that original MAC is no longer valid. When your phone gets it, it calculates its own MAC, compares the two, and immediately sees a mismatch. The tampered message gets rejected on the spot. The attack completely fails.
Okay, we've laid all the bricks, we've built all the walls. Now let's step back and take a look at the complete fortress we've just built. And there it is, the full hierarchy in one clean flow. It all starts with that root secret, key, on the SIM card. From there, we derive the KSME anchor key. From that anchor, we derive the KENB mobility key for the specific tower we're connected to. And finally, from there, we get the specialized keys for both control and user data. You see, every layer is systematically and securely born from the one before it. It's a beautiful cascade.
So here's the bottom line. Why go to all this trouble? Well, because this layered defense gives us incredible benefits. It contains the damage. A leak at one level doesn't doom the whole system. It gives us session independence. Old keys are useless for future sessions. It gives us real mobility security. And it drastically reduces the overall attack surface. It is a truly robust and elegant design.
This architecture is really the foundation of modern mobile security. But as we all know, technology never, ever stands still. And that leads us, of course, to the next evolution, 5G.
Now, as strong as LTE is, it's not perfect. It has a few weaknesses, like sometimes exposing a user's permanent identity, called the IMSI, over the air. So 5G takes the solid foundation of LTE and builds right on top of it, specifically addressing this issue by adding even stronger identity protection using public key cryptography. This helps hide that permanent identifier from anyone trying to eavesdrop.
This incredible key hierarchy is what protects billions of us every single day. But as we move into this new era, you have to ask, with all its amazing improvements, is 5G really the final answer to mobile security? Well, that's a great question, and one we'll have to explore another time. Thanks for joining me.